Hello students, welcome to online lecture series of discrete mathematics. Now, for today's topic is traveling salesman problem. So what is this traveling salesman problem? Generally, so salesman wants to travel from one city to the other cities, right? So whatever cities allotted for this salesman, so he wants to travel that cities from his home city, right? So he knows the distance of journeys between the every pair of cities, right? His problem is to select the route that starts from his home city and passes through the each city exactly once and return to his home city the shortest possible distance. So this problem is closely related to finding the Hamiltonian circuit of a minimum length. If we represent the cities by vertices and the road connected to the two cities edges, we get a weighted graph where every edge EI, a number of WI, where it is associated. Physical interpretation of the above abstract is consider a graph G as a map of n cities where W, there is I comma J, is the distance between the cities I and J. So salesman wants to have a tour of the cities which starts and ends at the same city. Include visiting each of the remaining city once and only once. So nearest neighbor method. So this procedure gives reasonably a good result for the traveling salesman problem. So this method has a different steps. So using this step, we can find out the shortest path for the salesman from this home city to the different cities. So here step 1, select an arbitrary vertex and find the vertex that is nearest to the starting vertex to form an initial path of one edge. This here arbitrary vertex means what? Start any vertex as a starting vertex, right? And whatever starting vertex you have selected, so find the shortest vertex from that vertex, right? Which one is the nearest from that starting vertex? You have to find that vertex and consider the path between these two vertices. Then step 2, let V, the vertex V, denote the latest vertex that has added to the path. Now, among the result of the vertices that are not in the path, select the closest one to V and add the path, the edge connecting V and this vertex. Repeat this step until all vertices of graph G are included in the path. So here, whatever vertices you have selected, right? So here, this whatever latest vertex that was added to the path. Now the vertices that are not in the path, right? Select the closest one to this V and add to the path. So here, step 3, join starting vertex and last vertex added by an edge and form the circle. So this nearest neighbor method is used to find out the Hamiltonian circuit, right? So here Hamiltonian circuit, we know the first vertex and last vertex are the same here. So joining the starting vertex and last vertex added by an edge and form the circuit. So we'll see the example for this nearest neighbor method. See this example. Okay. So here starting vertex for this example is vertex V1 is your starting vertex. So start with vertex V1, right? See here for this V1, right? Starting is V1. So here, whenever we find out the nearest, we are using the nearest neighbor method. So find out the nearest neighbor for this vertex V1. So how to find out the nearest neighbor? So find out the adjacent vertices of this V1. Adjacent vertices are this V2, V3, V5, and V4, right? So distance from V1 to V3 is 4. Distance from V1 to V2 is 5. The distance from V2 to V4 is 2. Sorry, V1 to V4 is 5, and V1 to V5 is 8. So minimum or shortest distance is 4. Shortest distance is 4. So select a path V1 to V3. So here we select the path. So next we select the path this V1 to V3. Next V1 to V3. So we add this vertex V3 in your path. So next, right? We reach at V3, right? So next path again, this V1 to V3. So next V3 to V2, 2. V3 to V5, 5, right? This is 2, this one is 5, and this one is 3, right? So adjacent, whatever adjacent vertex of V3 are V2, V4, and V5. So minimum, so nearest neighbor is this 2. So V1 to V3, V3 to V2, V3 to V2. So see here, it's V1 to V2, so V3, V3 to V2. So next, so here, V1 to V4 to V2 to V5, 3, right? So these are already we have traveled. These cities V1 and V3 are already traveled. So remaining vertices are V2, V4, and V5. So this V4 and V5. So V2 to V4 2, right? And V2 to V4 V5 3. So minimum is this 2. So V1, V3, V2, and V4. This is what the path V1, V3, V2, and V4. Next, so V4 to V5 is 2. So see V1 to V3, V3 to V2, V2 to V4, and at last V4 to V5. So this is the path from your this V1 to V5. So in this first and last vertex is same. So here we have to find out the shortest path from V1 to V1, V1 to V5 to V1. So V5 to V1, the shortest path is, see here, V5 to V1, the shortest path is 8. So just connect this V5 to V1, so V5 to V1. So this is your Hamiltonian circuit. You can say a circuit, right? So total distance. So just addition of these all the weights, right? That is 4 plus 2 plus 2 plus 2. That is 10, and 10 plus this one, that is, this is 8. This one is 8, right? So that is equal to 80. So total distance of this route is 80. So this is your nearest neighbor method to find out the Hamiltonian circuit. The next session is the next one.